Hello, everyone. I'm Janine Donnelly, Manager of Webinars for Tech Channel, and I'd like to welcome you to our presentation, Continued Innovation in IBM Z-System Sort Optimization. The presentation portion of today's webinar is pre-recorded. However, feel free to submit a question at any time during the event by entering it into the Q&A panel. You will receive an answer via email. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of today's slide deck by clicking on the drop-down menu labeled Event Resources. You'll find that on the left side of your screen, and know that you can download those right from the platform without being disconnected from the webinar. Today's webinar is sponsored by Precisely. Our featured speakers are Denise Tabor and Lisa Margulies. Denise is the Product Management Director at Precisely with over 30 years of experience in enterprise software. She worked closely with customers, partners, sales, marketing, support, and development engineers to provide innovative and efficient solutions to address clients' business challenges. Elisa has been working at Precisely for over 21 years. For the last 7, she's been supporting the Americas and Asia Pacific as a principal sales engineer for mainframe products, specifically SyncSort MFX and ZipSaver. And with that, let's get started.
Thank you so much. Appreciate everybody's attention today. So today we're going to be discussing continued innovation of IBM Z-System Sort Optimization. Inside today's agenda, we will do a brief overview of SyncSort MFX, and then Elisa will give you some tips for SyncSort MFX optimization. And then we'll wrap things up with discussing some important enhancements for our MFX customers. So let's start with an overview of MFX. Inside of everybody's IBM machine, there is something that IBM gave us called a Z Integrated Information Processor. Now, this is a purpose-built processor designed to operate with the general processors in the mainframe to help improve utilization of computing capacity and control cost. ZIPs allow customers to purchase additional processing power without affecting the total MSU rating. And what's interesting about that is that IBM does not impose IBM software charges on ZIP capacity. The charges will apply when additional general purpose engine capacity is used. So the bottom line is that once you purchase the ZIP processor, you can use them without any additional cost. And therefore, moving eligible workloads to a ZIP will reduce general purpose engine utilization and ultimately save software license costs. The big challenge here is that most workloads are not enabled to run on ZIP. Now, what we offer is a high-performance sort, copy, and join utility, which is designed to exploit the advanced facilities of the ZOS operating system and these specialized ZIP engines. Therefore, we can significantly reduce CPU utilization for sort operations and optimize I/O activity that will ultimately reduce contention in order to control software costs and delay CPU upgrades. This also frees up general purpose MIPS for handling increased data volumes and new workloads. Ultimately, we want to drive cost reduction strategies by reducing software charges and delaying CPU upgrades. There are several solutions that we have in our portfolio, and these are 3 of them. As I said, MFX reduces CPU time and I/O activity. ZP Saver is our solution to offload zip-enabled sort operations. And then MFX Pipe Sort will help you simultaneously execute differently sequenced sort from a single pass of the input data. As you can imagine, using parallel sorting technology can cut your total elapsed time by more than 50% compared to running regular sort output. So just to summarize about the SyncSort MFX family, we've been around for over 50 years, continual development and enhancements. Again, we take whatever workloads we can and offload them to zip to lower your CPU time. Our performance is optimized to help overall system efficiency. And we abide by encryption, security, and compliance regulations such as GDPR. So with that, a quick overview of the MFX family. I'm going to turn it over to Elisa, who will provide some tuning tips for SyncSort MFX. Elisa?
Thanks, Denise. So there are 2 main ways to tune SyncSort MFX. The first and easiest is to make use of the varied data manipulation features. In many cases, the use of these features can completely replace user-written programs. And the second way to tune SyncSort MFX is to ensure that the options in effect are set correctly for the given application and environment. But caution is recommended when performing this type of tuning, as the performance of other sorts and the performance of the system can be degraded by choosing inappropriate values for some of these options. So tuning a sort can be very simplistic or an extremely complicated task depending on what you're looking to accomplish and the complexity of your application and environment. The first step is to define your objective and to ensure that it's realistic. When defining your objective, you have to decide what you're willing to trade in order to get better performance. For instance, if you're seeking to reduce the elapsed time of a given sort, are you willing to increase the CPU time by X% to get a Y% reduction in elapsed time? Can you consider rescheduling either the sort you're tuning or other workloads? Can you move data sets to isolate DASD to be used by the sort, or make changes to the control statements used, or pass runtime parameters to the sort? Can you detune other applications to make resources available to more significant work? So the first step is tuning an individual sort is to ensure that you're using the optimal control statements for an application. So common errors in control statement specification that can adversely affect performance include things like using inrec when lengthening a record, or not using inrec when significant portions of the record could be eliminated. Using outrec when you're shortening a record, or using unnecessary sort fields, for instance, sorting on a social security number which is already unique and last name. Things like not using include omit to limit the number of records sorted. For instance, the following applications only process one type of record, but the input file has 10 different record types in it. Or using exit programs for functions that could easily be accomplished by using the sort features. For the optimization mode, the sort performance is typically defined in terms of CPU time, elapsed time, and IOs. At times, a performance improvement in one of these areas requires sacrifice in others. The optimal mix for these sometimes competing measures of performance is difficult to determine. A site's performance goals may even vary depending on the time of the day or even the day of the week. The opt mode parameter allows the user to define what measure of performance is most valued. The possible settings for opt mode are balance, CPU, ELAP, and I/O. The default is balance. Balance provides the best overall balance of CPU time, sort, elapsed time, and I/O activity. CPU minimizes the CPU time at the possible expense of elapsed time and IOs. ELAP and I/O similarly minimize elapsed time and IOs at the expense of the other measures of performance. The sort provides the ability to control the optimization mode based on the time of the day and the day of the week. Up to 24 separate time periods can be defined for normal weekday processing and another 24 for weekend processing. Most sites taking advantage of multiple optimization modes set the default optimization mode to ELAP during their nightly batch cycle and balance for the time period of heavier online activity. The optimization mode for an individual job can be set by a runtime parameter if the performance objective of that particular job doesn't match the default optimization mode. You should check the default optimization mode for the time of the job begins, and if it doesn't match your objective, you can simply pass the runtime parameter to change it to the correct one. In regards to virtual storage, the amount of virtual storage a sort has to work with is one of the most critical resources in determining how well the sort will run. It's also one of the most dangerous. Using too much storage can lead to system storage shortages like an IRA 400E or an IRA 200E and system outages. Extreme caution needs to be exercised when setting storage value for the sort to use. There are a variety of storage values used by the sort. VS Core T and VS Core are the two most important. VS Core T is the total amount of virtual storage the sort will use in its working set. This includes I/O buffers, record spaces, and control blocks. Nearly all of this is 31-bit virtual storage that's typically backed by real 64-bit pages. VS Core is below-the-line virtual storage that's typically backed with above-the-line real pages. The sort usually allocates only about 200K of this type of storage that's used primarily for I/O control blocks. The WER164B tuning message can be used to determine the amount of VS Core T storage used by the sort. Likewise, the WER410B message reports on the amount of virtual storage used above the line. To determine the amount of virtual storage used below the line, subtract the used value from the 410B message from the used value from the WER164B message. The delivered default for VS Core T is 6 meg, and the default for VS Core is 1 meg. These values can be adjusted up or down, but unless the system is extremely small, it's not advisable to adjust downward. The sort seldom uses the full megabyte of VS Core of VS Core, but it's recommended that it not be reduced. To determine the setting for VS Core T, the following is a good rule of thumb. First, estimate the amount of storage that will be available to the batch environment. Subtract the amount of storage used by started tasks, such as the ICS and DB2, from the total amount of storage on the system. Then divide by the largest number of concurrent sorts. You wouldn't have more sorts than initiators. Compare this value to 18 megabytes and take the smaller of the two. This can be used as your default VS Core T. In some circumstances, it may make sense to use a default VS Core T higher than 16 meg, but careful thought should be given. The VS Core T value can be overridden at runtime if the default value is not sufficient. If you're going to pass a runtime parameter to change VS Core T, do not choose a number smaller than 6 meg or larger than 64 meg. The minimum value of VS Core T should be at least 1 meg of VS Core T for each gig of data sorted. For better performance, this should be increased to 4 or 5 meg for VS Core T for each gig of data sorted. An interesting experiment is to run identical large sorts while varying the amount of virtual storage a sort uses. You can observe better performance as the amount of storage is increased to a point. From that point on, you'll see little to no improvement until you encounter the next significant point. From this point on, as you give the sort more storage, the performance will actually get worse. This is the point at which the cost of managing the additional storage and paging actually makes performance worse. The amount of virtual storage on the system is finite. If a sort uses more than it needs, then other application or sort cannot safely use that storage. It is important not to overallocate storage. SyncSort MFX has a facility called Global Dynamic Storage Management, or GDSM. One of the reasons GDSM was developed was to help sorts achieve better performance by dynamically adjusting the resources used by each sort. One of the important tenets of GDSM is that the system as a whole cannot suffer because of changes in resource usage made by GDSM. This can lead to a sort that runs every day at the same time, achieving different levels of performance. On days when the system is less busy, GDSM is able to make more significant adjustments to the amount of storage the sort can use. On these days, the sort's performance is good. On busier days, GDSM may not be able to make the same adjustment to the amount of storage used by the sort. On those days, the performance of the sort is not so good, or not as good, I should say. When the sort's performance seems erratic, one of the first things to check is whether GDSM is making widely different adjustments to the storage used. It may be necessary to pass VS Core T values to these specific applications in order to get them to achieve the performance that's required. An important input to the optimization process is the estimated file size. The sort has code to determine how much data will be sorted. There are only two circumstances when the sort is unable to get a good estimate. The first is when the input is read from a compressed foreign tape that has significant compression. The second is when the input is supplied completely by an input exit. The lack of a good file size estimate becomes an issue when the amount of data to be sorted is over a gig. Use of the file size parameter can supply the sort with an estimate of the amount of data to be sorted. This can significantly improve the optimization and performance of very large sorts. There's a point at which work needs to be done concurrently that can efficiently be done on a given system. The CPU capacity, real storage, and I/O resources on a system are also finite. Once the saturation point is reached, either more resources are required or work needs to be rescheduled during a slower period. PowerSort improves the elapsed time performance for sorts whose input is a multi-volume tape dataset and/or concatenated tape dataset. The performance improvement from PowerSort is a result of processing the sorting input volumes in a parallel fashion. Depending on the resources provided, the elapsed time can be reduced up to 33%. PowerSort requires additional tape drives for the application. The more tape drives that are provided, the greater the performance improvement. PowerSort will automatically manage the tape drives and minimize the use of them by deallocating excess drives during initialization and releasing all of the drives at the end of the input phase. SyncSort MFX is designed to improve programmer productivity by reducing the time a programmer must spend designing, coding, testing, debugging, and maintaining applications. Additionally, with SyncSort MFX's extensive data utility and report writing features, applications previously requiring several steps can be accomplished in a single step, thus improving the performance of the application. SyncSort MFX's data utility features include a join facility, a multiple output facility, a full range of report writing capabilities, record selection, and reformatting facilities. The individual features of SyncSort MFX are extremely powerful, but their value can be amplified when multiple features are used in combination with each other. The complete explanation, including the descriptions and syntax, can be found in the SyncSort MFX Programmer's Guide. We'll talk briefly here, but you can see all of them in that manual. Keep in mind, in order to be able to make use of all the features in the sort, it's also important to understand the sort's flow of control. And since here we're limited on time, you can also find that flow of control detailed in the Programmer's Guide. When we focus on reformatting records, records can be reformatted with the inrec, the outrec, and the outfile/outrec control statements. This is useful when all the information in the input record is not required by the following applications, or the data needs to be a different format. So the following can be accomplished with these types of operations. You can delete or repeat segments of a record. You can insert a new field, like creating a sequence number, or either inserting a current date or date function using the current date as the base. And you can insert a constant. You can convert data from any numeric format to a different numeric format. You can apply an edit mask to a field, or you can change an input field to a replacement field based on the value of the original field. You can convert from EBCDIC to ASCII or the reverse. You can convert from uppercase to lowercase or the reverse. You can convert to a printable hexadecimal format, or from one special date format to a different special date format. You can perform arithmetic operations with numeric fields and/or constants. You can perform min-max functions on numeric data, and you can change the record format of an output data set from fixed to variable or the reverse. The choice of inrec, outrec, and outfile/outrec can have a significant impact on performance. It's generally better to use inrec if you're shortening the record. If the record is being lengthened, the use of outrec will typically provide better sort performance. But care needs to be taken when deciding which control statements to use, as a specification of other control statements might be affected. When we talk about record selection, there are multiple ways that records can be selected for inclusion in the output. Once again, it's important to understand the flow of the sort and where the particular feature fits into this flow. The resulting output from the sort can be dramatically different if the record selection is performed in the output phase instead of the input phase. If the record selection is done in the input phase, you'll be working on the records in the order in which they appear in the input data set. If the record selection is done on the output phase, the records are seen in a sorted sequence. This point can best be visualized by thinking of the resulting data sets if only the first 5 records are requested. By doing the selection in the input phase, only the first 5 records are read and processed. If the selection is done on the output phase, all of the records are read and sorted. The output will contain only the records with the 5 lowest sort fields. Nearly all record selection is accomplished with the include-omit or out-file include-omit control statements. The following types of selections can be specified. You can skip the first n number of records. You can stop after processing n number of records. You can include-omit records based on comparisons of the contents of one or more fields within the record. You can include a sample of m records after an interval of every n records. You can distribute the records in rotation among all of the files in an out file group. Or you can create a file that contains only those records that were not included in any other out file. For join records, records can be created by a join process between 2 files that contain a common join key. Each record from the first file is joined to each record from the second file that shares a common key. If there are m number of records from the first file and n number of records in the second file that contain the same value in the join key, m times n records will be created. Join processing produces 3 types of records: paired records, unpaired from the first file, and unpaired from the second file. The disposition of records in each category can be controlled independently. The output from join processing can contain any of the combination of the record types. This feature is similar to the join processing found in relational databases. For summation, special processing can be done on records with equal sort keys. All but one of the records can be deleted, and the remaining record can contain the sum, average, maximum, or minimum value of specified fields in all of the records with identical sort keys. This processing will produce a data set that has only one record per sort key value unless an overflow occurs. If summation or averaging is requested and the resulting calculation will cause an overflow condition, the summation or averaging is not done. This will result in an output file containing multiple records with equal keys. Optionally, the records that are deleted can be written to a separate data set. SyncSort MFX provides a full range of report writing capabilities that can be used to quickly generate either one-time or regularly scheduled reports. The easy-to-use header and trailer features combined with the powerful record selection and reformatting features makes this an extremely useful facility. A sample use case for the report writer feature could be invoice status reports. These reports could be titled unpaid invoices, partially paid invoices, and fully paid invoices, which represent 3 output files generated with a single pass of the sort. These reports can then be printed or written to disk or tape. So just briefly, as we previously mentioned on one of Denise's slides, that Precisely offers several additional performance products. SyncSort ZP Saver is a set of enhanced technologies for MFX to offload copy, SMS compression, and sort processing to zip processors, effectively reducing the workload on the main CPU. ZP Saver can reduce TCB CPU time by up to 95% in eligible SyncSort MFX applications. SyncSort Pipesort simultaneously executes up to 8 different sequence sorts from a single pass of the input data. It uses advanced parallel sorting technology to cut total elapsed time by more than 50% compared to running these sorts separately. And SyncSort ProcSort is a high-performance transparent replacement for the SAS-provided ProcSort. It reduces CPU time required for sorting within SAS applications up to 50% and cuts sort elapsed time up to 40%. Because sort processing within SAS programs often consumes up to 30% of CPU time in EXCPs, SyncSort ProcSort's efficiency results in noticeable improvements in overall system throughput. And this is where I'm going to hand control back to Denise, who is going to continue with some of our recent enhancements. Thank you.
Thank you, Lisa. A lot of good information. And I just wanted to mention if anybody wanted some additional assistance with performing, doing some tuning on their sorts, please reach out to our excellent support staff and they would be happy to work with you and review your jobs. Okay, let's move on to what MFX team has been doing. Let me get to the next slide. So we have delivered already IBM Z-Sort Accelerator support. So what IBM did is they designed and implemented a new coprocessor on the Z15, and this was intended to reduce CPU usage and improve elapsed time. The accelerator speeds up sorting, it'll help shorten batch windows, and improve select database functions. IBM introduced this chip to accelerate internal sorts, but we saw an opportunity to exploit this new innovation. Precisely worked very closely with IBM hardware architects and the Poughkeepsie team to develop support for the sort accelerator. We then developed new algorithms in SyncSort MFX to take advantage of the coprocessor. We believe that customers in the right situations can expect to see dramatic improvements to batch sort job performance. And in our lab, we're seeing CPU and elapsed time improvements of up to 35%, depending on the key length, record length, file size, and some other factors. There's a knowledge base article out there outlining the situations that are best used for Z-sort, so I recommend that you go out there and do some research on that. I also wanted to mention our IBM Z pervasive encryption support. We delivered the ability, well, let me start first to explain what it is. The IBM Z pervasive encryption enables powerful encryption of data in flight and at rest, and provides highly secure ways to help deal with today's compliance and regulatory requirements. Unfortunately, even though we love pervasive encryption, no one really likes the additional resource consumption it takes to implement that. And the challenge to implementation is that it consumes processor cycles, so it does not come without penalty. For SyncSort MFX users, the input or output data set is encrypted. BSAM must be used instead of our high-performant low-level I/O access methods, and there's an extra cost from that perspective. Once again, working closely with IBM, we identified a way to continue to use our low-level I/O for encrypted data sets and improve encryption performance. We've seen great performance improvement from our benchmark testing, and although mainframe customers love the encryption approach, no one really likes the additional resources. But with SyncSort MFX alone, we've seen up to 45% CPU and 40% elapsed time savings. And combining MFX with SyncSort ZP Saver capabilities, we've seen up to 80% CPU and 40% elapsed time savings. And I will reiterate this, that this is only for the basic and large data sets where we continue to use our low-level I/O. So I'm not sure if that will help you, but please keep your emphasis with IBM and explain to them that they'd like the rest of the data sets to be handled as well. Okay, and the next area, this is something that we are working on because we have a lot of reports where customers need a little bit more insight into their sort workloads. Some of them are challenged with providing the right diagnostic information when they report a failure. In a way, we'd like to expedite the troubleshooting process and find ways to give you more exposure to what's going on with your sort workloads. Sometimes support would ask you to rerun a job just to gather debug information. So we're looking into finding ways where you can designate on your critical sort jobs to allow us to collect more job information so that if something goes wrong, then you'll have that readily available. The other part of this is to be able to provide more visibility into your sorting workloads. So there are many companies today that are using analytical tools, and I'm sure that you probably are too, to utilize in other areas of your business to do some analysis, things like Splunk or Elastic. So we want to find ways to collect the information about your workloads, provide you some historical data or real-time data so that you can find out what's going on in your environment. Our goal is to deliver a solution that will identify key pieces of information that you can both submit to support for review and also provide examples of ways for you to view your stored information and have you get the ability to define your own reports and dashboards. If you're interested in this particular functionality, I would love you to reach out to myself so that we can have a discussion about what your needs are. We would like to understand what kinds of details you would like us to know. And now we're going to pause here for a minute to field some questions.
Great. Thank you so much, Denise. It looks like we've had a few questions come into the chat box. I'll start with throwing this out there. With all the tuning options you mentioned, is there one that is most important?
Hi, I guess this is Elisa. I'll take that one. There's really not a matter of most important in terms of SyncSort MFX. It's really what's important for the user's environment and specific applications. I mean, as I said, there were a myriad of tuning options and installation options, the control statement flow of the sort. So again, if there's a specific application, send it to us. Support will be more than happy to help, take a look at your control statements and your installation options, and we can help you tune it.
Thank you, Lisa. We received this question. Do you need to have MFX in order to take advantage of zip offload and ZP saver?
That's a really good question. MFX does have some zip offload capabilities without the addition of ZP Saver, but you'll get the most value with the augmented ZP Saver because we can offload more workload to the zip engine. But inherently, there are some items that we can offload with just SyncSort MFX.
Wonderful, thank you. We received an additional question. Where can I find additional information on VS Core and VS Core T?
I'll take that one. So because of the dangers of miscoding or inappropriately coding values for VS Core and VS Core T, that is in the SyncSort MFX installation guide. Even though you can specify it as runtime parameters as well, we wanted to have caution and not just have anybody coding it willy-nilly out there. So if you need to code it or if you want more information, you can definitely look in the installation guide.
Great, thank you so much. That concludes today's portion of Q&A. If you have any further questions, feel free to put them in the chat box and we'll follow up with you post-webinar. Before we sign off, I just want to thank our attendees for joining us today. We thank you for your time and we look forward to speaking to you again in the very near future. Thank you and goodbye.
I want to thank everyone for attending today's webinar. Later this week, watch for a follow-up email. It will contain a link to the recording of today's webinar. Get all the latest on all things tech by going to techchannel.com/subscribe. That concludes our webinar. Thanks again, and enjoy the rest of your day.